Okay, and now I will solve from page 559, question 7b. I have solved 7a in class. Okay, here he said to replace the reactants at 0. So the energy of reactants equal 0 kilojoule per mole. The energy delta E أو the enthalpy of the forward equal negative 95 kilojoule per mole. The activation energy equal 20 kilojoule per mole. Okay, now I have to identify the three, I'll get out the three energies to be able to draw, which they are the reactants, and he gave it to me, the products, and the energy of the activated complex. From the givens he gave me, I can say that the energy of the forward equal what? Final minus initial, energy of product minus energy of reactants. Energy of product, I will know it now. I calculate it now. Reactants 0. Forward, he told me negative 95. So the energy of the products equal negative 95 kilojoule per mole. I will put it in a box here. What else do I have? Energy of reactants. Okay, activated complex left. So I use this now. I will use now the activation energy he gave me equal 20. Okay, activation energy, did he say prime? No, so it is for the forward. This means it is the energy of the final activated complex minus initial reactants. Okay, activated complex, I want to figure it out. Reactants is 0, so the energy of the activated complex equal 20 kilojoule per mole. Okay, clear now? As I have negative here, so I'm aware that when I draw, I will put the 0 in the middle. I will put the 0 in the middle. Okay, then negative 10, negative 20, negative 30, negative 40, negative 50, negative 60. I need to erase this. Negative 70, negative 80, negative 90, negative 100. Okay, and from the other side I can stop easily at, I need only 20, so I can stop at 30. Okay, in the exam you will have like a graphing sheet. Okay, it will not be like that. In the energy of the reactants equal 0, so the reactants are here. Of the activated complex equal 20, so it is here. The products are negative 95, so it is almost here. So this is your curve, and it is very clear that it is exothermic, and also from here, when he said negative, that it is here. When he said that it is negative, also I knew that it is exothermic before I draw. Okay, you will not stop here to just to draw it. Also, you have to label. First of all, you have to mention, is it exothermic or endothermic, and you know how. And now you will label it, the activation energy of forward, the activation energy of backward. What else? We can say the delta E, or the enthalpy of the reaction, which is between the reactant and product. Delta E forward, or when I didn't mention forward or backward, so it is the enthalpy of the reaction. Okay, and that's it. Easy. Let's do the last one. Here we will solve C. And by the way, tell Dunya that this textbook is her textbook, okay? Don't forget to take it from me. C. Delta E reverse equal negative 40 kilojoule per mole. And the activation energy of the reverse equal 30 kilojoule per mole. And he told me replace the reactants at 0, so the energy of the reactants equal 0. Okay, now I want to get what? Energy of product and energy of the activated complex. He gave me energy of reverse. Okay, energy of reverse. If I go back to the drawing, here I have reactants and here I have products, and here is the reverse. So where is my final? When I'm here, where is my final reactants? Where's my initial products? So as we said, it's all with the final minus the initial. The reactants 0. The products I will figure it out now. The reverse, he told me negative 40. So negative energy of products equal negative 40. So the energy of products equal 40. Energy of products equal 40 kilojoule per mole. Okay. What left? Activated complex. I will use that one. Usually, even from the name, the activated energy of the activated complex, from where I will figure it out? From the activation energy. Either the forward one or the reverse, the prime one. EA dash or EA prime, the reverse. Okay? The activation energy of the reverse, if I go back to my diagram, the activation energy of the reverse, that direction. Where's my final activated complex? Where's my initial product? Okay, the activated complex equal what? I will figure out. Product, I know it from here, it's 40. Activation energy, he gave it to me, 30. So the activation energy will be equal, when this go here, it will go by the opposite of the sign, so it will be plus 40. So the activation complex will be, the energy of the activated complex equal 30 plus 40, 70 kilojoule per mole. Okay, now 70 and 40 and 0, so all of it is above 0. I can do easily like that. This is my 0. It doesn't have to be here, so feel free to put it here or there according to your scale. And here, and by the way, to not freak out about the scale, because even we don't take enough time to practice in chemistry how to select your scale. Are you gonna use to count it in 10s and 15s and 5s? Okay, just make a constant scale. Yani don't put a scale like 110 and the other 5 and the other is 5. Yani like here 10 and then 15 and then 20. It will not work. Every scale have to be the same amount of scale. Like 10, you start 10, so it have to be 20, 30 and so on. Or you can start 5, 10, 15, etc. Okay, just unify the scale, that's it. I care about the curve at the end that if it is endo it kept endo, if it's exo it kept exo, and the reactants product and activated complex have the proper value. Okay, so here I have the reactants. I didn't put the scale. Okay, the bigger number here is 70, so I will say in tens. Okay, 10, 20, 30, 40, 50, 60 and 70. Activated complex at 70, products at 40, and the reactants at 0. Again, draw. The reactants to go up, it needs energy, so energy enters, so it is endo. So it is endo. Okay? And that's it. Also, if he asks you to label activation energy from reactants to activated complex. This is the prime one, and that's it. And from reactants to products is the enthalpy of the reaction. Okay? This is what we're supposed to practice at the last session, and we done. Please feel free to ask anytime on Teams, and don't freak out. And if you go through it, it's easy. Only the one and really just follow the steps, which is the calculation of the rate constant K and its unit based on math, not chemistry. If your calculations and when you move the reactants or the numbers from one side to the other side, are you gonna to change the sign? Sure, you will change the sign if it is plus and minus. But if it is multiplication, it will go on the other side division. If it is divide, it will go the other side multiplied. That's it. The power of tens. Don't put the tens in your calculator. Okay? The power of tens, do it aside. Do it aside. Simply. 10 to the power n. 10 to the power n divided by 10 to the power m. So 10 to the power n minus m. Even if there is no power here, when he say 10 over 10 to the power m, this means what? That it's 1. So it will be simply 10 1 minus m, no more. Okay? But if it is 10 to the power n times 10 to the power m, so it will be 10n plus m. Okay? And don't forget negative. If I have minus and inside a number that is in negative, let's say negative 10, what it will be? It doesn't show, sorry. Here, minus negative 10, it will be what? Negative plus 10. Clear? If I will move it here, it will be negative, and so on. Okay? The oxidation numbers, don't forget, if you have the compound like that one, it have a charge here, so it's not equal 0. Don't forget, this is not equal 0, it's equal that charge. If it is a pure element, 0. Clear? Clear? What else? I think we go through everything, and just read the textbook when you finalize everything or the notes, to go through the information in between. It will be like multiple choice, complete, etc. Practice, understand the text, that's it, no more. Okay? And if you found something I didn't mention it, never, like there is delta G, I didn't mention it, never, so it's, don't bother yourself about it. Okay? ويلا, good luck, have a nice day, bye.